Hello friends, my name is Vivek Sharma. Today we can cover this interesting problem that's called course schedule. So in this problem we have been given n courses and these courses are labeled from 0 to n minus 1. Okay, and some courses may have prerequisites. For example, to take course 0 you have to first take course 1. Okay, and which is expressed as a pair 0 comma 1. So let's do this. I copied these two examples here and let's see in the constraints if there is any constraints. So the constraint is basically the input prerequisites is a graph represented by a list of edges, not the adjacency matrices. Okay, and you may assume that there are no duplicate edges in the input requisites. Okay, so these are just the list of edges, right? This is not the actual graph. That's what the problem statement is saying. All right, so let's move on to whiteboard here and let's see, this is the first example and this is the second example. So we need to focus on this condition that we have been given, right? To take course 0 you have to first take course 1, right? So to take course 0, what does that mean? To take course 0 means 0th index course, right? So if I index these courses, this is 0th index and this is first index. So to take 0th index course, we have to take course 1 first, right? So this arrow will be like this. First of all, this course will be completed and then course 0 will be completed, right? So here one thing is keep in the mind that once we say course 0, it means the 0th index course, right? It is not the this value course, right? So if this 0 value is there, we cannot say that this is a 0th course. No, this is the first course because it is at the first index. So first thing we need to keep this thing clearly in our mind, right? So this is very important thing here. Similarly, these pairs are also 0 1 0 1 0 1 0 1, right, index wise. And similarly here as well, we need to take first course 1 before course 0. So these arrows will be like this. Why I am drawing these arrows? These arrows means they are defining, these arrows are defining the dependencies or prerequisite. Means first we need to take course 1 and then we have to go to course 0, right? So if I define them by the circle, let's say this is course, I mean this is this course 0 that I draw by circle here, right? So then this arrow will be like this. Okay, so to take course 0, to take the course 0 means to take the course that is at the index 0, we have to complete the course that is at the index 1, right? So this will be like this dependency. Similarly, if we draw this as well, 1 0, right? So 0 will go to 1, right? This arrow will be going like this because we need to complete course that is at the index 1 first, and then we need to complete, we can complete only at the course that is at the index 0, right? And that's what the problem statement is saying. To take course 0 you have to first take course 1, right? So that's what we are doing. Course 1 is this at the first index and course 0 is this that is at the index 0. Okay, and if I do it here, then I will have little bit more space. So 0 and then this is 1 and similarly 0 and then I will have another course that is labeled as a 2. Then similarly 1 is going to 3, so 1 will be going to the 3 here, and then 2 is going to the 3 itself, so 2 will be going to 3 here, right? So this is the dependency graph, right? This is the graph that we can uh, this is like the diagram or graph, whatever terminology you can use, but this is the diagram that we can understand that what is the dependency and what is the prerequisites among the courses, right? So what will be the output in this case? The output will be 0 comma 1 because this arrow is coming from 0 to 1. What will be the output in this case? It will be 0 1 2 3, right? Or another output may be 0 2 1 3. Why? Because it's going 0 to 1 and then 1 is going to 3, but it can 0 can go either first at 1 or it can go first, it can go either way, right? It can go either first 1 and then second time it can go 2. So that's why 0 1 2 3 is the valid output, or it can go first 0 2 and then it can go 0 1 and then 3. So 0 2 1 3 is also the valid output. So what is happening here? in order to complete course 1, we need to we need to first complete this course 0, that is labeled as a 0, and in order to complete course 2, we need to complete this course 0, right? So here it might be very confusing, because in the problem statement this is also 1 0, and then this is also 1 0, and that is confusing, I understand, right? So we need to focus on the index. When we say course 0, then it means the course at the index 0. When we say course 1, that is the course at the index 1, right? And here I am mentioning course 0 1 2 3 means I am talking about these values, right? I'm talking about these values. All right, so what does that mean? So these two outputs are there here. Now let's move on. Okay, now I think we are clear what we are going to do here. Okay, now how we are going to solve this problem? First step will be to understand this diagram, or to create this diagram, right? To understand the problem, once we are clear about this diagram, then we are uh, first step is clear, and then second step is the implementation part, like how we are going to implement the solution. All right, so now let's do this. Now let's quickly draw again that sequence diagram, right? This arrow, this arrow, this arrow, and then this arrow. Okay, so 0 is going to 1, 0 is going to 2, and 1 is going to 3, and 2 is going to 3 as well. So this is like the diagram that is showing the prerequisite conditions. Okay, so here whenever we are building our output, we can clearly see that we are starting from 0 here, and then we are going to 1, and then 3. So we are following the arrows here, and arrows play the very crucial and important role here. Why? Because we are going to apply the topological sort here, and as per topological sort, we apply the same algorithm, right? So if we don't know topological sort, it's fine. We are going to understand here what it is and how we are going to apply. So if there is any node in the graph that does not have any in arrow, right? That does not have any in arrow, we insert that node to the queue, and then we follow the same sequence, right? So we poll that in that node. Let's say for example in this case 0 does not have any in arrow. We will be inserting this node to the queue, and then once we will poll this node from the queue, and then we will see, okay, what are the other nodes that is having in arrow is 0, right? So in this particular example, there is no other node, right, apart from 0. So in that case, what we will do, we will poll, we will basically take any other node as well, right? So let's say for example, if we took one node here, the one, right, that is labeled as a 1, and this is having 1 in arrow, then what we will do, the next step will be to decrease this arrow, right? So if this arrow is 1, then we will decrease this arrow size as a 0, and then we will disconnect this node from this diagram, right? So let's say first we disconnect this 0. So 0 is there, and then 1 is there, 1 is having 1 in arrow. We will disconnect this, means like we will disconnect this connection, and then we collected 1 here, right? Similarly, 2 is there, that is also having 1 in arrow. We will disconnect this connection, and then 2 is there, right? And now 3 is there, so 3 we will disconnect this connection, and now 3 is having 1 in arrow. We will disconnect this arrow as well. Now it is having 0 in arrow, so now we will collect 3 as well, and that will be our output. So that is very high level design that we are going to use, right? This is very like very high level, but I think we should be very clear that what we are going to do here, right? So we should know that we are going to use the in arrows concept here, and whenever we have to know like which node is having how many arrows, we need to keep a track of those somewhere, right? We need to store those somewhere, like in some data structure, right? So if we have to keep a track like which node is having which how many in arrows, then I think the suitable data structure here might be the hash table, right? And that might be the in the key value pair, right? So for example, if we say 0, right? So node 0 node means the node that is labeled as 0 does not have any in arrow, right? So this will have 0 frequency, right? And then 1 1 is having one frequency because it is having one in arrow. 3 will having two frequency because 3 is having two in arrow. Similarly 2 will also be having one frequency because it is having one in arrow, right? And whichever node is having zero frequency, that we will start our journey. So we will be inserting this to our queue, right? So we will be inserting this 0 to the queue, and then we will pull this 0 from the queue, and then we will see the next. We will see the next means we will see the corresponding whatever the corresponding to the 0, whatever the corresponding to the 0 node, right? So the corresponding to the 0 node here in this array, two-dimensional arrow, is 1, right? Then we will go to the map, and then we will check, okay, what is the corresponding frequency? Oh, it is 1. What does that mean? It means it's not eligible to insert to the queue, right? Because we need the frequency as a 0 so that we can insert to the queue. So if it is 1, then what we will do, we will decrease the frequency, and then 1 minus 1 we will do 0 here, right? So we became this frequency as a 0. What does that mean? We will disconnect this connection, right? In other words, right, to understand from this diagram perspective as well. So if we disconnect this arrow, means we are making this frequency as a 0, and then we will insert this to our queue. Similarly, the corresponding to 0 is 2 as well. So then we will search the 2 in the map as well, and then this frequency is also 1, so we will do 1 minus 1 is 0. We will decrease, and then we will disconnect this connection as well. We will insert that as well to the queue. Now we will pull 1 from the queue, and then we will see, okay, what are the corresponding to the 1? So corresponding pair to the 1 is 3, so we will search here 3. Okay, so 3 is in the map, and here the frequency is 2, so we will decrease 2 minus 1, that is 1 here. Okay, so now if it is 0, then only we are inserting to the queue, but if it is 1, we are not inserting. So the criteria is it should not have any in arrow, right? So we will disconnect this in arrow, or we can disconnect this in arrow as well. Either of the one in arrow we can disconnect. And now 3 is having still one in arrow. Now we will poll 2, right? And we will poll 2, and then we will see in this two-dimensional array what is the corresponding pair to 2, and that is 3, right? So we will search 3 to the hash map here again, and the corresponding frequency, now we in the previous step it decreases to 1, right? So now 1 minus 1 we came to 0, right? So we disconnect this in arrow as well, and the frequency is now 0, and then we will insert to the queue. Now we will poll from the queue, and we will see, okay, is there any other corresponding to the 3? So there is no other corresponding to 3. It means all the nodes we already visited, right? So this will be our output 0 1 2 3. Whatever we are inserting to the queue, we can collect in our output list as well. So that is the basic idea to solve this problem. And if it is still not clear, it is very high level clear, it is perfectly fine. What we will do, we will create couple of placeholders, and then we will try to understand this concept here. So let's do this. Let's first of all create this hash table, right? So let's go ahead and create this hash table. So this is like integer, this will be the map, and let's call this as a degree map or in degree map, right? Something like this. So let's say in degree or in arrows map as well, we can say. Whatever more whatever name we can understand more, the same name we can use it here, because it is just a name, so it should be more intuitive basically. So in arrows map dot put, and now we need to put basically inside this, so int, let's say pre, and then prerequisites. All right, so in arrows map dot put pre, so where we are incrementing this to our in arrow, so here see wherever the 1, right? So 1 is having 1 in arrow, 2 is having 1 in arrow, 3 is having 2 in arrows. So these 1 2 3, they are at the 0th index. So whatever in the 0th index, we will be increasing one frequency here, right? So here 1 3 2, they are at the 0th index, so we will be incrementing frequency by 1, right? In that manner, what will happen, we will have the all the nodes that is having in arrow, And for example, in this case 0 does not have any in arrow. What does that mean? We don't need to insert. Even if it is getting inserted in our hash map, it does not matter, because we have to insert this into the queue, not the hash map here, right? So we don't need to insert it here because it is having the 0 in arrow. So there is no in arrow on the 0, right? So we will directly be inserting to the queue. And thus similarly for the other nodes as well, that is having some in arrows, we need to keep decreasing, and then we need to wait till it becomes 0. Once it becomes 0, they are eligible to insert to the queue again. And then once the degree is becoming 0, or the in arrows number become 0, then we are inserting to the queue, and then we are finding the next pair. So that's what exactly we are doing here, and that's how we are collecting the result. So anyways, that's pretty obvious here, right? So whatever the in arrows they are, we are just following that route, and that's how this algorithm works. So pre 0 here, and then in arrows dot get, or get or default pre 0 comma 0 plus 1. All right, so this is what we have stored the frequencies of in arrows. Now we need to take the queue, right? Queue integer. All right, so queue equals to new linked list. Now what we need to insert to the queue? We need to insert the queue to the queue whoever in degree is 0. In degree means there should not be any in arrow. So in this case, particular case is 0, but we need to generalize this thing. So what we will do, we will do integer I equals to 0, I is less than n. Why we are doing this? Because these nodes are labeled from 0 to n minus 1. See here, and that's why we need to take it here, right? So then we will check in our map, degree map dot get, or default I comma 0 equals to 0, right? Why we are taking this get or default? Because remember, 0 we are not storing in the map, because 0 does not have any in arrow. In other words, whatever at the first index, that will not have any in arrow, because the first 0th index will have the in arrow, right? So this 0 1 0 1 0 1 0 1, right? So we need to take first course 1 and to course 0. So these dependencies are like this. So this prerequisite is like this. So in other words, whatever is at the first index, they will not have any in arrow, right? uh, not the exact case. So for example, this in, if we see that this first index is also present at the 0th index, right? So this will have an arrow, because this will not have an arrow in this particular pair, but this same 2 in arrow, same 2 node labeled as a 2 will have the in arrow in this pair, right? So what I mean to say, initially we need some node that does not have any in arrow. So in this particular case is 0, because 0 is not the 0 is not at the 0th index in any other pair, right? So that will be the starting point. All right. So if it is 0, then let's go ahead and insert to the queue. Now if it is inserted to the queue, then now let's go ahead and take our output list as well. Int res equals to new int, and then this is n. And if queue is not empty, then we will be polling the course from the queue, okay? And then this course we can insert to our output list, right? We can insert to the queue as well, and then we can output to our list as well, because this is the list that we have to return in the end, right? So we will be returning return res. Okay, now what we need to do, once we found this course, we need to search this course in this two-dimensional matrix, right? So we need to search this course to this two-dimensional matrix, so that we find the corresponding 0th index course, right? So I'm doing here Control Z, but I think it's fine. Okay, so 0 1 0 1 0 1 0 1. Okay, and let me choose a different color. So now 0 is there in the queue. Now we will be searching the 0th index course here. So 0 is there, and the 0th index course is 1 here, and 0th index course here is 2. And once we find this 1 and 2, we will be searching this into the hash map, right? In the hash map, basically 1 is there and 2 is there, and their frequency is 1. So we will decrease the frequency. Once if it is frequency become 0, then we will be inserting to the queue, right? 1 we will be inserting to the queue, and then 2 will also be inserting to the queue, right? That's what we will do. And then again we will be finding 1 here, 2 here. So 1 is there at the 0th index, and then we will finding the corresponding 0th index. So this 1 is there at the first index, right? We will be finding the 0th index course, and that is 3, and then again we will be finding this 3 to the hash map, and we will decrease the frequency. So this is the sequence. Now let's convert this into the code, right? So let's go ahead and iterate this matrix, this given matrix. So int prerequisites hope the spelling is correct. And now let's check if because pre 0 we are already recorded, and we know that it does not have any in it basically having in arrows, right? And that's the frequency we logged. So the corresponding pre 1 will have this course, right? Corresponding pre 1 means at the first index. So this first index is the in our queue. So pre 1, if pre 1 equals to course, then what we need to do, we need to decrease the frequency of the corresponding pre 0. So if we find this 2 at the first index, then we need to get this 0th index course, and we need to keep decreasing the frequency in the hash map. So that's what exactly we need to do here. So we will be checking, okay, if my in arrows map dot contains key pre-0 means this corresponding pre-0. If it contains, then I will be checking what is the degree means how many in arrows are there in this map. So in arrows map dot get pre-0. If it is greater than 0, then what I need to do, I need to decrease the in arrows, right? So in arrows dot put pre-0 comma in arrows dot get pre-0 minus 1. All right. And now if in arrows having the 0 frequency means it does not have any arrow in, it does not have any in arrow, right? If this get is 0, then what I need to do, I need to insert that to the queue. So pre-0 is what? Pre-0 is basically this all these values, right? These are all the pre-0 means the 0th index course. Pre-0 is the 0th index course. Pre-1 is the first index course, right? So whatever is the pre-0 means these guys, they are having some in arrow, and I am decreasing those in arrows. And then once these frequency is 1 means there is no in arrow, then I am inserting that to the queue. All right, so very good. So now this process will go on, right? As we have seen in the whiteboard, first we did the 0, and then we found the 1, and then we go to the in arrow map, we decrease the frequency similarly, and then again we are inserting the corresponding, once we found this 1, this frequency is 0, we are inserting that to the queue. And also 2 for the node as a 2, if we decrease the frequency, then we are inserting that also to the queue, right? And then similarly 1 we will be finding in our two-dimensional array what is the corresponding 0th index course, and that is 3. Then we are again going to the map, and we are decreasing this, right? And then it became 1. And then what we are checking here, the 3 we will be only inserting, then once it will become this frequency will become 0, otherwise we will not be inserting, right? And then we poll 2, and then 2 also having the 3 here, and then we came here, and then it becomes 0, and then we inserted 3 as well to the queue. So this whole process we looped it here until queue is not empty, right? Until queue is not empty, we will keep collecting from the queue, and this will be our final result. Okay, another thing we need to do here, we need to keep decreasing the number of courses, right? Why we need to do this? So now let's not put this statement. Now let's first of all check the compilation error and correct those. Okay, so in arrows map, so in arrows this is the map. All right, let's correct other errors if there is any. Num courses, so this is not an num courses. Okay, this is m. Let's correct other errors if there is any. Degree map, so this is in arrows map. Okay, so this is also num courses here, courses. Okay, there are a lot of compilation errors in arrows map because the whole attention is to explain the approach, so that's why I made a lot of typos here, but there is no worry, we can correct those. So hopefully now it is syntactically correct and then there is no typo. So in this particular case it's working fine. Now let's consider the second example as well here, and then let's see what's going to happen, right? So 4, and then this is the one. So this is also working fine. See, the status is accepted. Now let's try with the another test case here. So let's say course is 2, and then one test case is 0 1, and then another test case is 0 1 0, right? So let's consider this as well here. So if I move to the next page here, so let's say we are having something like this, right? So 0 0 is having, or let's say like this, 0 and then 1. So we are having two pairs, right? 0 comma 1, 0 comma 1, right? And then 1 comma 0. What does that mean? We need to take first course 1 before course 0. So it will be, arrow will be like this, and then arrow will be like this. So 0 arrow will be like this, and then 1 arrow will be like this, 0. What does that mean? There is no node here that is having no in arrow, right? Every node is having in arrow. So in this case there is no node eligible that we can insert to our queue, right? And that's why we need to consider this case as well here. So now let's run our code and let's see what's going to happen. I think I made the mistake in the test case itself. So 0 1 1 0, I need to have the comma here. Now let's run it again. So wrong answer here. So the output, our output is 0 comma 0, but it should be the empty list, right? So we need to handle this case as well. This case means this particular case, that 0 1 1 0. So every other node is having the dependency of other nodes. So it is kind of the deadlock situation. So no course is going to complete, but the output should be the empty array, right? So that's why I was saying, like, we need to keep decreasing the courses as well. Num courses minus minus, and we need to make sure when we are returning our result, the num courses should be 0, right? Then only we are returning our output list. Otherwise return the empty list, empty array. So now it should work fine. Num courses, C is capital here. So now it's working fine, right? So that's why we need to keep decreasing. If there are 4 courses at the end of this algorithm, the course should be 0, right? So every iteration we will keep decreasing the step. In this particular case, what will happen? The queue will not have any node, right? So in fact, basically it should not enter to this loop, this while loop. So in that case, we will say, okay, course is still 2. Then it means we did not process those all together, and then let's go ahead and return the empty array. Let's not return these 0 comma 0, right? Because they are not the valid output in this particular case. So these corner cases also we need to take care. So I think this looks like working. Now in terms of the time complexity, what we are doing here in this while loop, we are processing all the vertices. So order of v will be from coming from here. We are maintaining our map as well to get all the edges as well. So basically we are processing here these two-dimensional matrix as well, that is the edges, right? So the complexity, overall complexity will be v plus e, vertices plus edges, and space complexity will also be the vertices plus edges. Why? So vertices we are storing into the queue and edges we are storing to our map as well. So this is from the space complexity perspective. Okay, now let's quickly go ahead and see if there is something wrong or it is working. So looks like this code is working fine, right? And there is another similar problem, right? This is course schedule. We solved just course schedule second, and this is course schedule as well, right? This is the first part. So in this problem, this is exact same problem. The only difference is the return type. We need to here figure it out whether it is possible or not to complete all the courses, right? And here we are returning that which courses we can complete. So we are building our output list, but in the other code, other problem, we don't have to build our output list, but we need to return true or false. So what I did here, uh, let me copy this code, right? So exact code, and then we will do very minor modification in the return type, and then it should work. So here we don't need the output list, right? So I deleted this guy, I deleted these output list as well. Okay, and here if num courses become 0, then we are going ahead and return true, otherwise we will be returning false, right? That's the only change we need to make. And this is also the same concept that we already discussed here, right? The only difference is here we need to build the output. What are the courses that we are uh, uh, that we can what are the courses that we can complete using this prerequisite condition? And here these prerequisite conditions are there whether it is possible to complete all the courses or not, right? So if in the end, if num courses has become 0, it means it is possible. If this num courses has not become 0 for these particular edge cases, right, if there's some deadlock kind of situation, then it is not possible, then we will be going ahead and returning false. So there is no other difference in the time complexity as well. It will be v plus e here because the exact same code, v plus e as well here. We just returned the res, we just removed the output list, that's it. There is no other changes here, not returned but removed. So we removed the output list. Now let's go ahead and compile this code. So now let's go ahead and submit. So you saw here, this is the exact same code that is working for this problem as well. So they are uh, pretty similar problem, right? The only difference is the return type. So hopefully this problem is clear. Now very quick recap before ending this video. These both problems are the prerequisite problem, means we have been given the prerequisite, means the predefined problem that we have been given the predefined instructions that we need to complete this course before this course, right? So in this problem we have been given, okay, we need to, if we need to take course 0, we have to first finish the course 1, right? So that's what we can see here, right? So course 0, course 1, course 0, course 1, course 0, course 1, course 0, course 1. Here the very important part is the 0th course means the 0th index course, not this 0 course, right? So this is not the 0 course, but this is the first course because it is at the first index. Once we understand this, we can create the diagram like this, right? This is pretty messy here, but similar, something like this, something, this is small diagram or the big diagram, right? So we can create this diagram and we can try to understand the dependency, like which course has the dependency, like which course we need to take first and which course we need to take second, right? Once we are able to uh, draw this diagram, we need basically two data structures in order to solve this problem. One is the queue and another hash table. Why we need to take these two data structure? The intuition is here, basically intuition is here that if we draw this diagram, we will see that okay, this 0 node does not have any in arrow, right? If it does not have any in arrow, that means it will start from the very first side, right? It will be very first node that we need to consider, and then we will follow all these in arrows, like whatever in arrows are there, we will flow in that direction itself. So we will be inserting this 0th node to the queue, and then we will be finding the corresponding 0th course itself, right? 0th course means 0th index course in this two-dimensional matrix, and also in the map, right? So map also we need to pre-record the in arrow frequency, like how many in arrows they are already there, and we will be finding those in the hash map. And then those frequency, if it is not 1, then we will try to decrease the frequency. We will try to become those frequency as 0. Once those frequency has become 0, we will again insert to the queue, and then we will again find the 0th index course, and then we will again go to the hash table, and then we will follow the same sequence until we find the until we decrease those frequency as a 0, and again insert to the queue, and then again find here. In this manner, we will keep decreasing this number of courses as well, one by one. Once this number of courses has become 0, it means we traverse all the courses, and then we will be returning our list here. And in this particular case, once the course has been become 0, we are returning true. It means it is possible to complete all the courses with the given prerequisites. And if it is written false, means number of courses is not become 0 in this process. It means it is not possible to complete all the courses, to considering this similar edge cases, right? This particular edge cases, like if it is some deadlock, or there might be multiple other edge test cases, but this is one particular test case that we can consider. In this particular test case, it is not possible to complete all the courses. So I hope this might be little bit useful. Let me know if there is some difficulty, or there is some other issues that I could not explain. I will try to clarify those as well. Thanks a lot. Have a good one. Bye.